the Automated Visual Detection Systems team. My name is Michael.
My name is Julia.
And I'm Ethan.
And we are looking to make agriculture safer in the 21st century. Now, you may or may not know, but agriculture is one of the most dangerous industries in the US and across the world. Many of the leading causes of death in agriculture are related to machinery. We want to be able to identify at least 20 types of different hazards with a 95% accuracy. That includes safety features like PTO shaft guards and hazards such as exposed PTO shafts. We want our system to have no higher than a 10% false positive rate, meaning we don't want our system to hallucinate and see hazards that aren't there. We also want our model trained on real data pulled from farm injury reports, statistical analyses, and OSHA regulations. We want our mobile interface to be very easy to use and accessible to a plethora of people.
Now, how do you get a computer to do all of these things, you might be wondering? Well, this is where our dual architecture system comes into play. We have a user web app for uploading images and data related to your equipment. And then we have a back-end interface which the user can access to train the model specifically. Now, we have a baseline model that we've trained on a plethora of different farming machines and equipment. And the way we've done that is we've built a companion web app to the user interface where you can upload your images directly. Say you have a niche type of tractor that our base model is not trained on. You can upload images of that tractor. You can train it either locally or using RoboFlow, using their cloud web services. You can train the model on those images, and you can export the trained model with knowledge and understanding of your specific machines to the main user interface, and you can use that model then to generate the report. Our YOLO model gradually increases in both effectiveness and confidence as you train the model. So say you're training on RoboFlow, the cloud web service system. You can choose how many times you want the model to run through your data set. As you can see, every round that you train the model, it gets better. Now, there is a limit to how accurate the models can get. As you get past 50 epochs, the return on investment decreases precipitously. And as you can see, there is a power law defining how accurate the models can get. Now, this is actually a good thing because it means once you get to about 50 or 60 rounds, there's not much better you're going to get that specific model.
Moving on to the technical interface, this is the browser client interface that will be running locally on your computer in a Python environment. So this is where you are able to upload the image. The image is then transported to the model using a Node.js server. And then the model then outputs an image with boundary boxes where it shows that it detected an object within the photo, and then it then classifies it with the labels on top of the boundary boxes. So as shown here, our model was able to correctly identify and classify a John Deere tractor. Underneath that is the processing options where you were able to adjust the confidence threshold of the model. And then that brings us to results. So during testing, our model had over a 95% equipment detection accuracy, and it has consistent, reliable hazard classification and report generation. And then because our backend uses a fast API integration, you are able to get a output photo within less than 50 milliseconds. And then to the right of that is an example of a safety and hazard report that our model generated. So this includes an executive summary of what hazards that the model detected within the photo that was uploaded, and then it includes inspection details with location, date, and then it'll include a list of detected hazards and risks from critical to moderate levels. And then moving on to the future capabilities, the first one being AI agent integration, which is an AI chatbot that you were able to interact with, and it'll explain detections, guide you through safety concerns, and provide clear recommendations based off of what the model has seen. Moving on, we have full video analysis and real-time analysis, so our model only uses photos, but we would hope in the future to integrate video footage or live analysis where the model is able to detect hazards and risks in real time or as they come across the screen in footage. And then lastly is enhanced model accuracy. So this is training the model with company-specific or content-specific images that better match the equipment and environment that the model can detect hazards accurately